think we're live. Think we're live everywhere. Appreciate people joining. If you have, I'm back with another coding challenge. I know it's been a minute trying to get back on it, trying to drag myself back to it to try to practice some of these things. I took a little break. But yeah, now I'm back on it, trying to do another one. This one's an easy one from KG.codes. I'm gonna start easy, then I'm gonna try to go back to mediums and then go back to hards. But yeah, I'm gonna give it a couple more seconds and I'm gonna jump right into the problem. Hopefully it makes sense. Hopefully I can do it without hiccup. But if not, we'll learn together and all that. So it should be pretty good. All right, yeah, I think I'm gonna jump into it. This one is called Climbing Stairs from LeetCode.com. It's an easy problem. Supposedly it's asked by Amazon, Adobe, and Apple. And the problem goes as such. You are climbing a staircase. It takes n steps to reach the top. Each time you can either climb 1 or 2 steps. And how many distinct ways can you climb to the top? And so we have some examples here. If n is 2, so I guess n means that's how many steps it takes to reach the top. So here's 2 steps. The output is 2 distinct ways you can climb to the top. So the output is 2 in this problem or example. So the 2 ways are 1 and 1. And then if you just do 2 steps, since you can do either 1 or 2 steps on each iteration, each thing you do, I guess, in the, as you're walking up the stairs. It's kind of a weird problem because it's like each time, yeah, I guess that's each iteration. And then there's example 2, where if n equals 3, the output is 3. There's 3 ways that you can do it with 1 or 2 steps. You can do 1 step, and 1 step. You can do 1 step plus a 2 step, or you can do a 2 step plus a 1 step. So I'm looking at this problem. Oh yeah, here's the constraints down here. It's one of n has to be greater than 1, so it'll always be at least 1 steps that you're trying to do to reach the top, and then it's in between 1 and 45. So it could be equal to 1, or it could be equal to 45, or somewhere in between. So that's probably just capping this problem off. Because if this number gets really high, then the number of ways, the combinations can get probably out of control. So I get why they're probably saying trying to cap this out at 45. But anyway, for people that's just joining, the problem's called Climbing Stairs. And it's about how many combinations of 1 or 2 steps can you make to climb the stairs where n is the number of steps. So how I like to do these problems, if you ever watched me before, is I like to try to think through the solution first, and then I try to take that what I think with the solution and try to apply it to code using data structures, algorithms, and techniques that I'm familiar with. So I've done this problem before pretty recently, so hopefully I can remember what to do, and I can kind of identify the pattern or identify the approach that I need to take here. So when I look at this problem, I see that it's like when I see stuff like how many distinct ways can you do something, or how many distinct patterns, or how many combinations there is or something, that's already triggering my pattern recognition to be this problem is going to need some sort of it's going to need some way to find different combinations. Basically, it's like I can't even say it. Combination problem is what I would call it. And so there's a certain technique you can do for that. But when I think about this, I know that I need to, if I have n, I basically need to, for each step, I need to try either 1 or try 2 steps every iteration. So I know I need to have some sort of loop or some sort of thing that can trigger different iterations. And basically for each iteration, either try 1 step or try 2 steps. And then I need to see if my result of adding 1 or 2 steps equals n. That means I've reached the top of the staircase or whatever. So basically like I need to loop and try these 1 or 2 combinations every time, and I need to count up every time I get a combination that equals to the n. I need to count that, and so I need to find how many different like ways or combinations of 1 and 2 steps it will take to get to 2 steps. And really, the climbing stairs part is kind of like it's a way to like kind of contextualize the problem in the world, but really it's kind of like a combination math problem type of deal or something. It really didn't have to be climb stairs. It could just be that just kind of gives it a real world scenario to kind of like layer on top of the problem. So anyway, like how I would solve this would be to use recursion. Probably like use a function that I can keep calling recursively in order to find all the different combinations. And I would keep a running tally of my steps at any given time. And for each step, I would add 1 or 2, and then I would return back if when I add 1 or 2 equals my final, n, my number of steps to reach the top. And if it does, I'm going to add 1 to my result. If it doesn't, I'm not going to add anything. And so by the end of it, after I keep calling this recursively, basically kind of looping over it, I should have the answer, which is how many distinct ways I should climb to the top. This is a really hard one to explain. So I'm going to try to just jump to the code and see if that makes more sense for folks. Sorry if people are commenting and stuff. It's kind of hard to like concentrate on the problem and also answer the comments but I'll try to answer some stuff at the end. Anyway, I'm going to jump over to the problem. I'm going to use JavaScript. I know a couple people asked for Python. I don't know Python. So I'm going to use JavaScript. And yeah, so what they do on KG.codes is they go ahead and like scaffold out a function for you to write your answer in. And here, the first thing I'm thinking about doing is I know I need to return a number of ways, basically. So if I think about that, the problem is asking for a number of ways. So I know I need to return something, about that's going to get that for me. And the thing I know I need to do is I need to be able to step by step call a function to give me the number of ways at each interval. And how you can do that is create a function that you would call recursively. And I'm not going to put any parameters in it yet, but I'm just going to scaffold out this. And so I'm going to call this here in climb stairs, but then I'm also going to call this recursively inside of itself as well. And so some of the things I know I need to pass into my function is n. And like I said, I need to keep a track of the number of steps I've taken already so I can figure out if I've got a valid combination, basically, or a combination that equals n. And so hopefully this makes sense to folks that are watching so far. So anyway, if I'm going to keep a sum, so let me write this function first. So let's say this is n. This is just keeping track of n. And then this is the current steps that we've taken. And so here, when I first call it, the current steps that I've taken are 0, of course. And so when I first come into this function, these type of combination problems, what you have to do is think about at each step, what do you need to do at each. So when you call this function recursively, what are you trying to do? And here I'm trying to return the number of ways based on n and based on the current steps that I am already. So one thing I know is that if, like I said before, if my current steps already equals n, so you say current step equals n, I know that this is a valid combination that I've gotten to. And so I don't need to know what the combination is. I just need to return that there is a valid combination. I need to count the number of ways, the number of combinations or whatever. So here I can just return 1 that I'm going to add. Like in this case, it would literally only be 1. And so I know if current steps equals n, I know I can return 1. The other scenario is if current steps, or let me see, if current steps is greater than n. So let's say I added 2. I did a current step where I added 2 and it went over n, then I know that that's not a valid combination. I need to kind of like prune it from the results, or just not add anything at all. So in that case, I'm going to add 0 in that case. And then here's kind of like the more interesting part. And like this, I don't think this would be something, I want to take a step back. I don't think this would be something that you would know off the top of your head. This would be something you would have practiced. This type of algorithm is something to find combinations, basically, recursively, using recursive function, or using recursive function calls. This is something that you will have practiced. The trick is the problem recognition. And for people that are joining this stuff, let me put the problem over here, because I know some people don't know what the problem is. It's called climbing stairs from KG.codes. You are climbing a staircase. It takes n steps to reach the top. Each time you can either climb 1 or 2 steps. And how many distinct ways can you climb to the top? So I'm actually going to put that, I'm going to try to put that over here on the other side so people can see that. Yeah. All right, so that's up there now, and I'm going to keep going. But so yeah, like I said, this is something that this is an algorithm that you could use for different types of problems for sure, and something that you would need to practice. That's why it's good to learn the foundations and learn the algorithms first, so you can recognize the problems that they're needed for, and then use them in the problems. Not saying somebody couldn't figure this stuff out on their own, but it could be difficult, or it could be unnecessarily strenuous on you to do that. So anyway, the last thing I need to do, if current steps equal n, I know I need to return 1 to add to my number of ways. If it is greater, then I don't need to return anything. This way isn't a valid way, because it's current steps went past n. You're over the top of the stairway. And the final step is this is where the recursion comes in. I basically need to say number of ways past my n in, but for current steps, I'm actually going to add 1 step. And then, so I need to try, basically each time it says you can climb either 1 or 2 steps. So I need to, here, I'm going to try climbing 1 step. And then I'm going to add to that. Whoa, what happened? Okay. This thing is in the freaking way. Okay. Number of ways. Actually, I'm going to try to so you guys can see. Number of ways in. I'm going to pass n in. I'm going to add 2. So this is basically what this is doing, is saying for my next step of recursion, I want to try with adding 1 step, and I want to try to add in 2 step. And so when this function gets recursively called, it's going to come back in here and basically say, like, is current steps equal to n, or is current steps greater than n? Don't return anything. If it's equal to it, return 1. And so by adding these together, I'm recursively, by the time I return this function up here finally returns, it's going to have added in all the different combinations or number of ways together using recursion. And so I hopefully that makes sense. I know it's a little bit, recursion can be like a difficult concept on its own to understand as well. How I'm basically calling this function, like think of the movie Inception with Leonardo DiCaprio, where he was like going in a dream inside of a dream inside of a dream. If you're really early on, in programming, you may not understand the concept of recursion, but that's basically what it is. You're calling the same function inside of itself. And the main thing is you need to have some sort of way to terminate the recursion, so you don't get stuck in like an infinite recursion loop, or infinite, basically, yeah, like an infinite, your whole program will time out or whatever. So yeah. So I think this is right. Yeah. So this gives me step 1 plus adding a step, like the scenario when I add 1 step and the scenario when I add 2 steps. And then these are my termination logic here to basically say when it equals a step, then I got a new way. And when it is greater, then I just go ahead and get out. I just, end it right there. So I think that's correct. If you were in an interview scenario, what you usually would have to do, it depends on the company. Some companies ask you, they'll have a IDE or whatever you can run the problem in. Some companies don't. They just make you trace through it by hand. I don't know which I want to do. Maybe I'll try to just run through it since in my head first. You should kind of do this anyway if you have time, but the problem is some of these interviews, they don't really give you a lot of time. So it's like you almost like they want you to do that. Yeah, you should trace through the code manually first to make sure you find any bugs and all but then they only give you 15 minutes for an easy problem. So, it's kind of contradictory to me. I mean, you have to be so fast. So, but I'm going to try to do it for the sake of learning. So let's say n equals 2. Let's do that example. And then I'm going to probably put these down here so I can see what's going on. N equals 2. This is how I usually do this. I make comments and I just keep track of all the different variables that I'm using. I think this is all I need to keep track of so far. So let's say if n equals 2, we're going to come into this function with current steps equals, we're going to come in right here where n equals 2. Current steps equals 0. And so that's going to call number of ways. Number of ways is going to get called or whatever. We're going to come in with the state of n being 2, the state of current steps being 0. Does current steps equal n? No. So we're going to skip over this whole thing. Is current steps greater than n? No, because current step is 0. So we're going to skip over this. Then we're going to go recursively into these two functions. So the first one, we're going to come back in with current steps plus 1. So if we come back to the top of here with current steps plus 1, then it would equal this. And then we would come back in here. We would say is current steps equal to n? No, it's not. 2 and 1. Is current steps greater? No, it's not. So then we're also going to come back into recursively back into this again. And recursive functions like this, or recursive logic like this, it's hard to trace because I'm gonna have to like go backwards and like run the logic all over again. I'm gonna have to go back to I'm skipping calls that because I'm going down a recursive tree. I'm gonna have to kind of like backtrack and close off all the execution that I haven't got to yet, if that makes sense. It's kind of hard to explain. But yeah, I'm going to go back into this recursive function again. I'm going to add another 1. So I'm going to get 2. Finally, current steps plus 1. Sorry, current steps equals n, 2 and 2. So I'm going to return 1. And so then I would come back out of this function. And then this would go back. It's kind of hard to explain, but this would actually go back to 1 because I would come out of the recursion I was in before and run this line. Because remember, I didn't even run this line yet. I went into this line and came back into this function. So if I run this line where current steps equals 1, I get current steps plus 2, which makes it 3. And then that basically would bring me in here where it doesn't equal. So I skip this. It's greater than, so I say 0. So then if I jump out of that recursion, then like I had before, the number of ways, I got 1 on the first one and I got 0 on the second one. So that will return 1. But then I already had jumped a step of recursion before that. So then that means only this one is 1, and then I need to go where current steps equals 0 to this one. It's kind of, it's really confusing to explain, but I probably need to track this better. with recursion, but it's still correct. So I basically have 1 right here. Like this equals 1. The first time we ran this function recursively, this function produced 1. And now I need to go down this train, but hopefully this one's quick because current steps equals 0. So that means current steps plus 2 equals 2. I come recursively in this function again. I get current steps equals n. Yes, it does. So I return 1. So now I can backtrack back out of that. And here I actually get another 1. And so number ways equals 1 plus number ways equals 1 equals 2. Up here, that means this ends up equaling 2. And let's see. Over here it says, yeah, for input 2, the output is 2. And for my outputs here, I did get 2. So I know that was kind of hard to explain, but that's recursive. So I mean, that's recursion. Like it's very hard to track like outside of just your mentals. I mean, I guess you could maybe find a way you could track like the level of recursion you're on. Maybe be easier. And yeah, for people that asking, sorry, I'm not seeing the comments. I'm just trying to, it's hard to solve these problems and try to read comments and answer comments too. But I'll try to answer some stuff after. So I'm solving the LeetCode problem. If you haven't seen it, it's at the top here. It's called Climbing Stairs from KG.codes. And I'm basically done. What I did was I just wrote some code, some comments to try to solve it like manually, because in some interviews you're going to be asked to like solve it manually without being able to run it in the IDE. Like I've been in interviews where they said, hey, write the code, test the code with some example input, and that's it. Like you're not gonna be able to run it and find it. You need to find the bugs yourself, not use the compiler to find the bugs, or use the runtime, to like some runtime error or whatever to find bugs. But sometimes they let you run it, and luckily LeetCode actually lets you run it, or fortunately it lets you run it. So I'm gonna run this. And I got accepted for both test cases. The first test case I ran through manually, n equals 2. The output should be 2. The second test case is n equals 3. The output should be 3. And that's correct. And so this is probably where I'm going to have a problem. And I'm going to show y'all. How did I get rid of this console? Here it is. I'm going to show y'all the issues that I might have with this logic that I wrote. So what LeetCode also lets you to do is submit it against all other it compares it with all other people using LeetCode and submitting an answer to this problem. It also gives you the runtime, the runtime in milliseconds, like time complexity, or not time complexity, but gives you the runtime in seconds and gives you the memory in megabytes or kilobytes, I think, something like that. And yeah, the other thing is the one thing you'll probably be asked in an interview is the runtime complexity of the problem, or the time complexity of the problem in big O notation. That's something that you'd have to prepare for before the interview to know what it is. I don't even know if I know what this one is. If y'all in the comments know what the runtime complexity of this is, let me know. I'm going to try. I know we have n. I'm just trying to think what's big O time complexity is always tied to the size of the input. So what's tied to the size of the input here? That would, I want to say this is just big O of n. No, it's big O. No, because it's 2. I need to erase this, but it's two paths I go down here. So basically I add 1 here and I add 2 here. So I like split trees recursively right there. So it's actually, this is a weird one, but I think it's like 2 to the nth power, because I have 2 options at every interval, at every step. And so however big n is basically 2 to the nth power, big O of 2 to the nth power time complexity, I believe. And space complexity, I think, is big O of 1, which is constant space. I'm not storing anything besides the recursive functions that sit on the stack while it waits for the recursive functions to complete. So I mean, that does use space, but I think in big O notation, I don't think that usually counts. So I think it's just constant space there. But I'm gonna check that after I get done. But I think it's time complexity is 2 to the nth power, I believe. But somebody can look that up and double check me on that. Cool. So I'm gonna run it against LeetCode. And I think I'm gonna have a problem here. I'm pretty sure. Because the time complexity is 2 to the n power is not great. It's not good at all. So time exceeded. So I think my solution was correct, but it's just very slow. And so LeetCode puts a time limit on your solutions. And so I think after a certain point, with 44, it just maxed out. It's just like we can't, your algorithm is too slow, time complexity wise, 2 to the n power. So what can I do here to fix this? It's a technique called, I'm just going to go right to it. I don't think this is something you would just come up with on your own. But this is why you solve these problems and try to learn different techniques so you can apply them to different problems. But somebody said it, memorization or memoization. I don't even know how to pronounce it. But it's basically like memorization or just basically saving some of your dynamic programming is a solution too. I'm not gonna go down that route, but one solution you can do to kind of help with the time complexity is use like memoization. And so what I'm gonna do is actually a lot of times in these problems you can save on time complexity by using space. So increasing the space complexity, trade off the time complexity, use some space to save on time complexity, if that makes sense. So save something in memory in a variable or in a data structure. That's why these problems are usually called like data structures and algorithms or whatever. You can use some sort of data structure to help you solve the problem in less time and reduce the time complexity. But you're going to trade space for it, and sometimes depending on your scenario, depending on the real world, sometimes space is more important than time. Sometimes it's not. But in this case, I'm using way too much time, so I'm going to have to trade off for some space. So what I'm going to do is put in a JavaScript object here as one of the parameters. I'm going to call it, memorization, or I don't even know, saved or something like that. I just call it saved. Wait, is this? Yeah, okay. Call it saved. And basically what I want to do is I want to save some of my results, because what's happening here, the problem I'm running into is that I'm recalculating the same result for every step over and over and over. So it's like I may get the same, like my state here is n. N is always the same. Current steps is the one thing that's different, and then I get a result here. And so what's happening is sometimes all these different strings, the recursive paths that I'm going down to find all these combinations, sometimes I get the same amount of basically I'm like recalculating the same answer for the same current steps. And so I can save that value. The first time I hit, I can save it in a variable, and then the next time I need it, I can just pull it out of the variable, which is constant time. It's big O of 1, constant time, if you pull a value out of a map or object or whatever. And so that can help me save like massive time by doing that, instead of going down these recursive paths over and over again when I already know the answer for a certain current step. So let me explain what I mean, instead of because I'm struggling to explain it. Let me just do it. So what I can do is I can have this saved object, and I can basically say, instead of returning it immediately here, let's save it into, for this current steps. So whatever that current steps is, let's save it inside of here. And why did this go all like weird? Anyway, okay, yeah. And then I could return saved. I could just return the saved value. Whoa, what did I do? Current steps, I can just return the saved value here. Yeah, so yeah, I can just return the saved value here. Yeah, so now I've saved it in, for this current steps, I've saved this result inside of it. And the one other thing I need to do is say, if I already have it, then don't even try to recalculate it. Like, just return it out of here. Matter of fact, I probably can do like, this is gonna look weird because I can't, because the lines keep wrapping. But basically what I can say is, if I have current steps, use that. Otherwise, and this is a ternary, yeah, so I think I can do this actually. But then that'd be like resaving. I actually don't want to do that because that's like gonna be more costly. So never mind. It makes the code cleaner, but it actually makes my algorithm worse. So I'm gonna not do that. So basically what I'm saying is, I'm gonna save this in here, but in order to take advantage of those savings, I need to check if it's in here already, then just use it. Like, don't even, and just return it. And it's probably even better for me to, I don't know, store a variable here and then return it through a variable, but then that's gonna, take up some space. So, I think it's probably fine. I can say save current steps, put that in there. And then if I have current steps, then return it. And then don't even resave it here. Uh-oh. Am I still online? Oh yeah, I'm still here. Sorry, I froze up. Yeah, so I'm not even gonna save that. Yeah, and I'm just gonna return it instantly. So I think this is right. Yeah, saving it here, returning it. Yeah, let's see if this works. So I did something wrong here. Can saved. Oh, so I see where I messed up. This is why you try to trace through your code before you run it, but I'm trying to cut this video short. So what I didn't do is I didn't pass saved, and I need to pass saved inside of my functions here. It's like, what the heck are you doing? Yeah, and I think that should do it. Whoa, how did it get over here? Okay, let me run it again. So I got the wrong answer for this. It's 3, not a number. So I did something wrong here. Let's see. Save current steps. Save current steps. Save current steps. Save current steps. Number of ways. Plus save. Number of ways plus saved. And return save current steps. Yeah, I don't know. Oh, here's what I did wrong. Didn't return this. So I got all kind of bugs in here, but at least I can figure it out. Why did that go over there like that? All right, so yeah, now I got the right answer for the quick test that I ran. And now I want to see, I keep doing that. Now I want to see if run it against LeetCode, if it'll actually pass this time. Yeah, thanks somebody for mentioning that, me missing that current steps return. Appreciate that. All right, so yeah. Now it actually passed instead of getting time exceeded like last time. It only beat 9% of LeetCode submissions, but it beat 60% on memory, which is pretty good. I'm going to be confident in that for the sake of this length of this video. I'm going to take that win. Yeah. And so for this one, what's the time complexity for this one? I think the time complexity actually goes down to big O of n because I'm saving the steps that I've already taken. And so at max, I would have saved a step for every like 1 through n, basically. And so the space complexity would actually not be constant anymore. The space complexity would go up to, so let's see, space would now be big O of n because I would have this new saved object that would store up to n entries in it for each current step, possible current step. At worst case, that's what big O is measuring, is the worst case. And the time, I think, is also now big O of n, but somebody can correct me if I'm wrong. I won't pretend to just know 100% that. And everybody's saying, please go dark mode. I'm like, man, dude, I don't even do dark mode like that. But shoot, how the heck do I do that? I don't even know where to go to do it. I'll do it for next time. For my next video, I'll go dark mode. Sorry about that. I didn't know it was like killing people like that. But multiple people said that. So anyway, the space. So this brings it way down. And that's why I was actually able to run this time, because the time complexity wasn't big O of n of 2 to the nth power. It was just big O of n. So for every n, I basically run some type of operation. So I hope that makes sense. This is an easy problem, but to me, the reason I did this one, it has some tougher concepts in it, like recursion. It doesn't have your typical common big O complexities in it. It has you can do it one way and then optimize it. It's kind of like a easy medium to me. And when you're first starting, it's actually like a medium hard when you're first starting. When you get really good at these, then yeah, it'll go down to an easy. But I don't always believe what LeetCode says about being easy or hard or whatever. But yeah, and somebody said, how would you make this quicker? I'll answer some questions now. Probably dynamic programming. Actually, let's look at the LeetCode solutions. I think they'll probably have multiple solutions in here. I think it's here, editorial. So yeah, the approach one was brute force. Let's see what this one is. Yeah, this is the same thing I did. So this is where I had the two. I used a recursive function. I have the two thing. I did it a little different in their order, but I have like the two functions that break me out of the recursion, so I can add to my number of ways or either not do it. And then I recursively call these functions again with +1 and +2. That's brute force, and I was right. So it's 2 to the nth power. The size of the recursion tree will be 2. See, I didn't even know to talk like that. The size of the recursion tree will be, I guess I was talking about the paths and stuff like that, but I wasn't thinking about a tree. Oh yeah. So yeah, these are the combinations. And so yeah, you get big O of, so that's really slow. 2 to the nth power is not a good time complexity if you can help it. And the space complexity, so I got that wrong. The space complexity is big O of n already in the first brute force solution. The depth of the recursion tree can be up to n. Yeah, so it goes by the depth. So yeah, that makes sense. Yes, it wouldn't be, because it would still, the number of operations you do. No, but yeah, I did say that, but I thought it didn't count. Yeah, the recursion stack can possibly, so the depth that you get to could be up to n. Okay, that makes sense. Recursion with memoization. That's always weird to me. It's like, why they just don't say memorization? Memoization. It's a weird word to me, but yeah, that's what it is. So I think this is my new solution. Yeah, so they call it memo. And basically you store inside of here, return it. And yeah, this is basically my solution. I'm not going to go through it again. So I did get the big O notation right on this one, which is much better on the time complexity. And it's the same on the space complexity. So I actually did pretty good. I didn't add any more space complexity, but I just changed the way I was using it. So I think it actually adds more space complexity, but not enough that it changes the big O notation. Because here I'm doing recursion and I'm storing in a data structure. So, but it just doesn't change related to the size of the input enough to change the big O notation here, the big O in space complexity. So that makes sense. Approach number 3, dynamic programming. This is the solution I did not do. I probably don't even understand how to do this, honestly. As we see, the problem can be broken in subproblems. Contains the optimal substructure property. Its optimal solution can be constructed officially from optimal solution of its subproblems. We can use dynamic programming to solve this problem. We can reach the ith step in one of two ways. Taking a single step, taking a step of 2 from that step equal to. So yeah, I don't even understand this, man. I mean, I probably could if I took some time to just understand it, but right now, just looking at it, no, I do not understand it. This is interesting though. Oh yeah, I see. Yeah. It makes sense, but yeah, I wouldn't have came to this on my own for sure. And let's see. It's not really faster though. So, oh, it's another solution, Fibonacci number. Ah, yeah, this do make sense for like Fibonacci. Because it's the 1-step and the 2-step thing. So this one isn't faster, but it does save you some space for the Fibonacci one. It's too many answers to this problem, man. I'm not even gonna read through all these. So this one is big old log n. Dang. I think that's faster. Yeah, so I guess that's how you would do it fast. I'm not gonna go through this, man. Maybe I'll go through this one in another live or something like this. This is getting pretty complicated using the matrix, Bennett's method, and all this. I will not lie, I'm not familiar with none of that. So that's interesting though. Dang, it's approach number 6. How many approaches is it? Wow, that's crazy. Yeah, man. Somebody said, do you have to know math? No, you don't have to know math to answer these. Or to be a programmer, answer these, or nothing like that. You don't have to know math at all. Dynamic programming, it doesn't make sense. Yeah, dynamic programming is a weird phrase, for sure. Somebody said, isn't it crazy how people have worked out these problems and have thorough explanation? Dude, this one was hard. Now, if you watch some of my other videos that I explained, I feel like I explained them very well. Like, people gave compliments, stuff like that. But this one was hard as hell to explain. I ain't even gonna lie, man. This one was tough. But Talking Tech with D, what's up, man? He said math helps for sure. Yeah, math definitely helps. Yeah, for sure. I'm just saying you don't have to. You can find a career, in programming, tech, without just being like a math whiz. I mean, now, should you just be like total, just totally just don't know nothing about math? That's probably not a good thing. But I don't think like certain roles, you're not going to use math all the time, or you're going to, you're going to leverage something else to do the math for you. Leverage the language, leverage the framework, leverage, Google, whatever to help you do the math for you. And then in answering these problems, I think having an understanding of math definitely helps. But don't let what I want to say is don't let that prevent you from the reason you asking that question, because you maybe trying to find a reason that you can't do it, or like a reason to discourage you. Don't let the not knowing math discourage you. That's what I'll say. But it is good to know it for sure. Don't ask me how to explain it though, unless you're going through graph related problems. This was a weird one to be trying to do like a graph or matrix and stuff for. Like, this one is like, it's crazy that like all these solutions. I am surprised by the number of different solutions they have for this one. That's why it's almost like not easy to me, especially when you first starting out. Yeah, look at these comments here. This problem's definitely not easy. Wow, mind blown. Yeah, it's a lot going on with this problem. It's interesting. I'm glad I picked this one, actually. This dude saying it's not a good solution. Yeah, a lot of opinions in there. For sure. Yeah, man. Let me see if there's any more questions I want to answer. I love when people jump in the comments talking, man. Thanks for people for joining. Caden, thanks for joining on here. Definitely talking tech with D. Definitely love his content, man. He keeps it 100 for sure in everything he posts, man. That's why I like his content for sure. I don't even want to call it content, just the stuff he shares on there, on here, on TikTok actually. And sorry if anybody else, I'm on everything right now. Facebook, Twitch, YouTube, all that. If you want to watch somewhere else, you can. I don't think I got any comments anywhere else though. And Instagram is down right now, so I didn't stream on Instagram. I'm like, they tripping. I don't know how it's down again. It was like down a couple months ago. Can we try to walk through the dynamic approach? That's funny, T. That's funny, man. Hell no, I'm not. I ain't doing none of these other approaches. Like, I've stepped through brute force, and then I found this one. I mean, you could get in an interview where they might go that far. I mean, I've been in interviews with small companies. I've done some FANG interviews. I've done some ones in between. It would be really weird if they had you do all of that with this type of problem. I've never seen that. A lot of the harder problems that I've gotten asked by like Amazon, Airbnb, like they're more like tree problems, graph problems. Like they're just different than this though. This would be weird if they asked this and then had you. But I don't know. I mean, this could be. I don't know. I just if an interviewer asked this, man, it'd be pretty interesting. But I'm not gonna rule it out because it's on here. Somebody probably asked it somewhere, but I feel like the return on what I want to say, yeah, this is what I want to say. They could ask this, but I feel like the return on investment for trying to learn this would be not as high. Like you should go and just do like what's the problem called? Number of islands. Like just, if you want to try to learn about like matrices and graphs and stuff like that. So anyway, let's see. Anybody else say anything before I jump off of here? It's kind of strange. Yeah, like it says, Sean says, yeah, it feels kind of strange. They want to introduce weird terminology. Yeah, it's weird. It's like, I guess they're just showing you every single solution. But at my company, if we was interviewing somebody with this problem, we would like, the person probably would do the brute force first. And then I probably ask them how they can make it faster with memorization. That's probably as far as it would go. Now, if they came up with this on their own, like to do dynamic programming or do these Fibonacci stuff or some of this other stuff, then it would have been brownie points and it would have been great, and they probably would have got it quicker. They would have got it better. But that just it seems like it would take too long. Like if you got to do all this to answer an easy, you got to answer an easy most places in 15 minutes. And if you got to do all of this to answer an easy, it's like it's taking too long for you. Like it's got to be a lot quicker. But yeah, memorization is definitely something they will ask about for sure. It just depends on the company. Some companies have really easy ones, easy leak code problems that don't even get to the point of like memorization. But some companies, man, I was at a couple of interviews, man. The whole 45-minute interview was one problem. And it was crazy. I knew the answer, and one of the interviews, I knew the answer and couldn't finish it because it just took too long, like to write it. Like you have to. That's why these problems are such a game to me. Even though I do them because it's a necessity for certain type of companies that interview like this. You have to kind of keep up with it. But it's a game, man. It's like it's just memorization. You just memorize it. That's why I don't even go through the whole thing of like I used to do these on here and say, hey, can you get your mind to just like figure these out on your own? It's never like that. When you practice these, what will make it easier for you is find somewhere that gives you the fundamentals. I use Algo Monster. You can go to other places, coding, Groking, the coding interview. There's a couple other resources that give you all the patterns. They give you like this pattern is one of the patterns in Algo Monster. You learn how to do that recursion pattern that I did to find like combinations and stuff like that. And once you memorize that pattern, and then this pattern recognition, you recognize, okay, this problem's asking for combinations. Apply this pattern to it. It gets a lot easier once you can do that, and it don't feel like the world of problems is so big. It starts to like get smaller to like these like 15 patterns that you've memorized. So you're not memorizing the solution so much. You're memorizing the code that you have to write for these different patterns, and it gets a little easier once you can do that. But there's always edge cases where these companies are trying to like they're trying to like trick you and try to like get outside of the game, I guess, and try to like ask stuff that's like, not never seen anywhere else type of thing. But I don't know, man. When I did my last round of interviews, I used LeetCode and I bought the premium version and ordered it by the companies, and not like at least 50% of the problems from every company would show up directly from LeetCode or be some modified version of it. And so it was pretty cool once it got to that point. But you just have to be sharp, So you have to practice, memorize the patterns. But yeah, it gets easier, man. Because I thought it was unsurmountable at one point to learn how to do these problems. But and I was really resistant. I was a hater. I had like 8 years in the industry. I was like, I'm never gonna do those problems. Like if they place interview like that, I ain't never gonna try to interview there. And I just had to get over that pride, man, and just say, hey, I'm going to try to learn this. No one's smarter than me. I'm not smarter than anybody else, generally. And I can learn this stuff and do it. And eventually I'm not saying I'm the best, but I've gotten to a point where I can do them online here for people. And this helps me. This helps me, explain myself in interviews and stuff like that. It's dual purpose. But yeah, I got to the point where I was able to pass some interviews that did all LeetCode, and I was like, this is crazy that I went from like terrified, like never thinking I couldn't solve an easy problem, to like passing like a FANG interview that did all LeetCode problems, which were like that would have like 5 years ago would have been like I never could do that. Like, so it's crazy, man. But yeah, I mean, I just say all this to say don't be discouraged. It gets easier once you practice. So how do you get noticed for interviews? That's a tough one. I mean, you just have to, and I don't even want to say you just have to. It's tough. I mean, get on LinkedIn. Make sure your LinkedIn profile is fleshed out. Make sure your resume is fleshed out. Try to find recruiters. Reach out to recruiters. You should be filling out, like, if you're really trying to get an interview, you should be filling out as many applications as possible in a day. Like, when I was looking for jobs, even now with a lot of experience, I mean, it's not crazy to fill out 50 50 applications or 100 in a day. And I mean, if you can do more, do more. And then it's a numbers game. Eventually, you're going to start getting interviews, I promise you. But see, what most people think, they like, oh, I ain't getting no interviews. And they see us getting interviews or somebody else getting interviews, and they think they just filled out 5 applications to their top companies and they got an interview. No, some of these folks, man, they filling out like crazy, and it's easy these days too. That's like people like when I first got in the industry, man, you had to actually fill out the application one by one. Now you can freaking hit button LinkedIn quick apply. You can just quick apply the junk like one button click. It's no excuse. You should be like putting in to like a lot of applications. Yeah, easy apply. Yeah, I mean, now if you don't have any choice, if you can't do easy apply, then yeah, you should be putting out a lot of applications a day. Like when I first got out of college, now I get people pursue me just because I got a lot of experience. But when I first got out of college, I was filling out 50 applications a day. Straight up, no easy apply, all that stuff didn't even exist yet. So, I mean, it was like monster.com. I think it was what it's called. Yeah, Monster. Career Karma. I don't know what the heck it was called. Career. Dang, what the heck was the name of that company that help you with get jobs? Career something. Yeah, and it was like Indeed or whatever. It's like all those little job sites. I was just filling those out. But yeah, and yeah, then once you get the interviews, then yeah, now you can practice and pass them. But yeah, Career Karma, I think it was Career Karma. But yeah, you get interviews. Now you work on the next step of trying to like pass the interviews. And sometimes you got to take a couple L's, man. Like I'm 10 years in, and hey, I took L's in the last round of interviews. I took some L's, like straight up. Like I don't care how far you go, you're gonna take some L's. People just don't talk about it. People like to act like they. I wouldn't say like that. Not everybody likes to act like that, but they definitely don't share it. Like they just share I got a new job, and they make it seem like it was just like they didn't even fail in the interviews. But people fail interviews all the time. If you really going out there trying to interview, you're gonna fail some interviews. But see, what happens is once you get a lot of experience, a lot of times you've worked with so many people, you got a lot of experience, you got connections. So then you sometimes can get jobs without having to truly interview. But if you go out there and really do you ain't using no connections and just interviewing, you gonna fail some interviews. Like these tech interviews, you gonna fail them. Some of them. Like you might have a good record, but you gonna fail at least one or two. If you do 5, you gonna fail at least 1 or 2. So, or for some reason you gonna drop out of it. Like you just gonna be like, I don't want to do this, or you gonna burn out, or whatever the case is. Something's gonna happen. So yeah. Anyway, I had a comfy tech consulting gig fall through my hands. Fall through your hands? Dang, what happened? Recruiters don't go through all them applications, just look at the top ones on their emails. Yeah, that's a good point. Like, so like that's why I said like you need to fill out a lot of applications, but at the same time, if your resume ain't working, then you gotta like it's obvious, like you have to improve the resume. Like it's just the sad truth. Even if you think it's ready, for some reason it's not, and so that may mean you need to do more side projects. Maybe you can take some contract jobs and put them on your resume as like contract work. That's what I did to get my first job. I did I didn't call it freelance on my resume. That's the trick that I didn't call it freelance. I actually like got contracts with these companies and like work with them to build a website or build whatever for them. And it was it's just contract work or contracting or whatever you want to call it. Like I didn't like using the term freelance on there. I just used that, hey, I'm just working. These companies are contracting me to do some work for them. And that's how I put it on my resume. So that's a little, just don't start lying. But, that's I feel like a little wording hack you can use on your resume to kind of like make your experience, validate your experience a little more. Because it is valuable experience if you really did it. Now, don't just lie. You know what I'm saying? Because you start lying, then you just get caught up on it. So somebody said I had a take-home assignment. Yeah. So yeah, like I'm doing lead code problems, but not every company do lead code problems. Like I've gotten some take-home things that were like beautiful, and it was just. Or I even had one where we got online and the dude turned his camera off. He said, "I'm gonna let you work on it by yourself for an hour." It was like a UI component I had to build, and that was just a beautiful interviewing experience. Now I didn't go with the company for other reasons, but it's just like. Some people are getting hip, or companies are getting hip to how gamified this elite code and data structures questions are, and they're starting to change the process. Like Stripe was a big one. Stripe is a really big company that you would, or I wouldn't say big company, but it's a well-known tech company that you would think would do lead code, and their process, they actually don't do any lead code, and they're really proud of it. So I thought that was interesting. And they're not the only ones. It's a lot of companies don't. My company I work for now, they definitely do lead code. I have to do lead code. I have to give people lead code. Sometimes, man, I feel so bad for the people in the interview. But they like make us do lead code. I started not doing it when I first started interviewing. And I was like, man, I'm not going to do lead code. I'm going to interview like I used to interview before the company, decided to make us do it. And then they were like, no, you got to do at least one lead code problem or one data structure and algorithm problem. I'm like, man, this is stupid. So I try to be, as friendly as I can. I usually lean toward easier problems unless they're like senior. Then I'll try to maybe do like a medium or something. I don't go real crazy on it though, because I'm not gonna sit there and do a 45-minute hard problem with a candidate. I only got 45 minutes. I ain't met them. I don't know nothing about their history. I don't know nothing about their personality. All that stuff matters way more than them being able to solve a 45-minute leak code problem. Like, I need to know that I can work with this person. This person could be the best leak code dude in the world, best developer in the world. One thing I learned over my career, if you can't work with a person, it don't matter what they can do. Nobody wants to work with them. Then you got them isolated on your team. Because I used to do management. I used to be a software development manager too. And like, if I had somebody on my team that nobody wanted to work with, now I got problems. I got to try to like organize the work so this person doesn't get mad at this person. Like, nobody wants nobody like that. So I can't sit there and ask you no leak code problem for 45 minutes and not get to know you or get to know about your experience either. Because I know a lot of people that interview well, but they get to the job and they distracted. They have like issues with, focus, or they just don't understand stuff well, or they understand how to interview, but they don't understand the day-to-day and some of the concepts that come in software development day-to-day, and some of the things that we have to do and the way we need to think. And so I need to know all around how you go. And leak code, for me, it's like a small part of the interview. But we're kind of made to do it. Or at least, I don't know, at least that's what I thought we're made to do it. So, anyway, I went on a rant there, but, hopefully it's helpful to people. Yeah, some interviews focus too much on knowing syntax instead of being a good problem. Yep. That's the one thing about it you're going to learn. You already know this, I'm sorry. And some of y'all probably know this. I'm just saying, that's one thing I learned at one point, is that not every interview is a good interview. Just because they interviewing you, or just because the company let them interview, doesn't mean they just some kind of like, they're just an expert at interviewing. Like, most people actually suck at interviewing. I might suck at interviewing. I ain't even going to say I'm that great at it. Interviewing is a skill, but like what companies do, they just think anybody could just interview. And they just let everybody interview. There's no like rules to interviewing. Like, there's no trainings, and some companies try to do some stuff, but it's not good enough. Like, they don't have like some, like our company, well, I won't say nothing about my company no more, but some companies have like, hiring experts and stuff, but like no one's, like, a lot of times people not taking no training. They just doing what got done to them. And sometimes they use it as a chance to just brag about how good they are instead of actually interviewing you. They just try to just show how much they know. They use it as a way to build their own confidence. Or like you said, they don't really test for the right thing. Do you know how to do this leak code problem? You're a bad developer if you don't. And that's not even a right bar to be measuring. Like, it's a lot of factors you need to measure about a person to know if they're going to be a good developer, and it matters about what your team is looking for as well. And you're looking for a good coworker. Like, you shouldn't just be looking for some, dude that can interview well. You know what I mean? Because it is a different skill. Interviewing is a different skill. It's a lot of overlap, of course, but it is a completely different skill than the day-to-day work in a job. Especially this leak code stuff. It's way different. So anyway, I don't know how long I've been on here. I appreciate the people that's joined. I appreciate the people that's commented and talked to each other. I know I missed a lot of comments. It's hard for me to do these kind of problems and talk at the same time. So I try to talk after. And then even then I get on these rants and miss comments. So if I miss something, please DM me or whatever. If you have a question or you want to talk or whatever, like if you DM me, we talk, I follow you and we can like connect or whatever. Follow each other, connect with each other. I like when people, I like to comment. I like when folks get on here and help me out, answer some of these comments, man. Like, cause it's just, I meet so many, there's a lot of great, people on, all these platforms that are in tech that know a lot more than me or just have a different perspective than me, so. Yeah, if you had to pick 2 to 3, this would be the last question I answer. This is a good question. If you had to pick 2 to 3 resources like leak code to help you get a job, what would you pick? Well, it depends on the role I'm going for. But if you're just talking about trying to be a software developer and you're trying to get into any company, like you want to get into a big company, for instance, then you're going to need to know data structures and algorithms. So I'll answer to that since this is the context of this video this live that I'm doing. The first resource is leak code. You can't get around leak code. It's the top resource to practice problems on. It's the one most of the problems going to show up in the interview from. It's just because it's the most popular. Not that you can't use others, it's just you have to use that. The other one's Glassdoor. Go on Glassdoor, go click on find a company, click on the interviews tab. There will be problems in there from real interviews, and put in the title that you're going for. Find those problems. There'll be leak code problems in there. There'll be behavioral problems, like general questions they ask you about your experience and about what would you do in this situation, stuff like that. You can find a lot of the answers there. Blind.com and the Blind app has the same thing. A lot of problems, a lot of interviews. Just search on there and the interview, and you can find questions. So that these resources help you like learn what's going to be on the interview to prep for the interview. And then the other thing, you need to, if you want to learn more about algorithms and stuff, I would say Algo Monster is one I recommend. Algo Expert is another good one. But what I mentioned those because you need to learn the foundations first before just trying to do 1,000 problems. You need to learn, how to do what is dynamic programming. What's breadth first search? What's depth first search? When do you use those things? What's binary search? When do you use it? What's the 2-pointer technique? When do you use that? What's like the fast, slow pointer technique? What's, it's all these different techniques that you need to know. What's the thing that the recursion that I did today, and why would you do that? How do you, find combinations and things like that? Like Algo Monster will teach you those like 15 techniques in order of priority based on return of investment or based on how frequently those questions are being asked by some of the top companies. And then a lot of these smaller companies just end up emulating the top companies. So those are the things I would suggest. I know it's a lot, but yeah, that's what I suggest to try to get good at doing data structures and algorithms problems, as well as once you got an interview upcoming, give yourself some time and then go to glassdoor.com, go to blind.com or that Blind app, go to LeetCode. You can also get LeetCode Premium while you're interviewing and try to find your company that you're interviewing for, that, especially if it's a big company. It doesn't work for the smaller ones, but for a big one, search by the company and order by frequency. Those problems will show up in the interview. Like, I've seen it firsthand. Like, maybe not every time, but for me personally, they have showed up. So I'm giving that as advice because it helped me. Like, I got the interviews and literally had just done the problem, that exact problem the night before or the day before, 2 days before, whatever. So anyway, man, before I lose my voice, appreciate y'all. Like, follow, subscribe, all that stuff, whatever platform you're on. I'm on all of them live. I'm going to do these more often. I'm going to start doing some more Q&As. I'm going to start doing some harder problems. Go look at my old videos if you want to see me do more of these problems, different problems than this one. But yeah, just give some encouragement. Like, if you're just learning this stuff, keep going, because I was there at one point. Like, even after being a developer 8 years in, I sucked at data structures and algorithms. I actually like didn't like them. Like, I would like talk about them all the time and say I will never do these problems. And it was a pride thing, and I got over it. I got better. And so if you're trying to learn the code, trying to get a new job, trying to learn, data structures and algorithms, just keep going, just keep practicing, find the resources, DM people, DM me, talk to each other, all that stuff. But yeah, other than that, y'all have a good night. Appreciate it. I'll see y'all in the next video. Appreciate it.